Okay, so in this video we wanted to go over, or I wanted to go over the equation of a line and how we write it out in three-dimensional space. So the idea is, if I have my three-dimensional grid x, y, z, and I have some line in space, where'd my grid marker go? There it is. Okay. If I have some arbitrary line like this cutting through space, how do I define it? And there are different ways to do this, but the way we're going to do in this class, since we're working with vectors, which make our calculations and our problem solving a lot easier, is to do this in terms of vectors. And the idea is, in order to define the line, I need a point, p sub 0, and I need a vector, or, well, I guess we'll say a direction vector. We'll write it that way. Because the idea is, if I tell you I have some point right here on the line, say that's p sub 0, and I tell you I have some direction vector like this that tells me the direction of the line, then clearly, if I have this direction vector and I have a point, then I can just use the direction vector to move along the line, and now I have a way to define my line in terms of vectors, which is what I want. The question becomes then, how do I kind of use that from a problem solving perspective? And so we're going to kind of manipulate this a little bit. I have to keep changing colors. Okay. We are going to say p sub 0 is equal to a point. Well, I'll just say x sub 0, y sub 0, and z sub 0. My direction vector, I'll call it u, and I'll say it's the vector a, b, c. Now, if I kind of quickly draw this out, I'm going to alter that picture slightly right there. So if I draw this out right over here, if I draw a vector out to p0, which is my point, I'll call this vector r sub 0, just so it agrees with p sub 0. I'm going to pick another point on the line, which I'll arbitrarily say is right here, and call it p. And I'm going to draw the vector out to there, and call it r. Now, in order to define the line, I need a point on the line. I have it right here, p sub 0. I need a direction vector. So just because I drew it this way, I'm going to say this is my u right here, my direction vector. Now clearly, if I went in this direction, I would go through the point P. And my goal is to be able to find a way to algebraically find this point or any point on the line if all I'm given is a point and a direction vector. But now I can kind of manipulate this algebraically. Let's see. If that's the vector r sub 0 and this is the vector r, then this is clearly r minus r sub 0, just using our definition of subtraction of vectors. But now, the direction vector u and this vector r minus r sub 0 have to be going in the same direction. Clearly, this is going along the line, that's the direction of the line. Which then tells me that if these are parallel, then the vector r minus r sub 0 has to be, I use beta in class, but I'm going to use t here, has to be a scalar multiple of u. That's what it means to be parallel. Now I can work with that. So let's see. Well, I guess if I want to write this slightly differently, I'm going to add the r sub 0 to the right, and I'll get r equals t u plus r sub 0. And now just use my information there to kind of manipulate this. Oh, I left off my r sub 0 when I added it. Okay, that's r sub 0 right there. Clearly r is this vector, which is going to that point, which I can just call x, y, z, since I don't know what it is. Equals t, u is my direction vector, which is a, b, c, plus r sub 0, which is a vector going to p sub 0, which means I can just write it that way. X sub 0, y sub 0, z sub 0. Then I get xyz is equal to save time, because you all know how to do this, distribute the t in, scalar product, then add the vectors component-wise, and that's a vector, not a point. Always don't make these pointy enough. Let's see, I'll get the vector ta plus x sub 0, tb plus y sub 0, tc plus z sub 0. Do it again. But now I know these two vectors are equal, which means now they have to be equal component-wise. And now I get that x has to equal, here I'm going to rearrange this because this is just the real number, x sub 0 plus at. Y equals y sub 0 plus bt. Z equals z sub 0 plus ct. And now I have parametric equations that define the line, that tell me all the points on the line. X sub 0, y sub 0, z sub 0 is my original point that I started with that was on the line. This is essentially the vector, the direction that will go along the line. These t's, as I pick out different values of t, I'll get different points along the line. And if I use all t's, say t, just let it be a real number, then I'll generate the entire line. Clearly, if t is 0, I get x sub 0, y sub 0, z sub 0, which is that point right there. Now I can use this to define lines. So, I'll leave that on the board really quickly, but right over here, suppose we have this. Let's see. Find a representation of a line passing through the point 1, 2, 3, parallel to the vector v equals 2, 4, negative 3. So, I have a point on the line, a p sub 0. I have a vector parallel to it, which means the direction is the same as this vector. So I have my direction vector. Now I can find a way to actually represent it. And let's see. In this case, I could just jump to the end, but really quickly try it out formally. I can say r is equal to t times, I used v for this, so t v sub 0 plus r sub 0. So xyz is equal to t times 2, 4, negative 3 plus r sub 0, which will be 1, 2, 3. And then I get xyz is equal to, here again, I'll do the scalar product and then the vector addition, but I'll reverse it. So I'll get 1 plus 2t, 2 plus 4t, 3 minus 3t. And now, since they're equal like component-wise, I get x equals 1 plus 2t, y equals 2 plus 4t, z equals 3 minus 3t. And now those are my parametric equations to actually graph out the line. Let me see, is there anything else that I wanted to do with this? No. Okay, good. Next up, 1, 2, 3, this is all of that. Yeah. These are the basic definitions and how we use the equation of a line and write it out. I'm going to make a video with planes and then do some of the examples we did in class. But again, these videos are designed to be relatively short, so I'm going to stop this one here. I'll do another video for planes and then another video going through a few examples.